Okay, now we have the parallel perpendicular video 2. We're going to talk about just a quick review. We're looking at slope of a line. If your slope is A over B, the slope for a parallel line would be, Luke? Yes, A over B. The slope for a perpendicular line with the slope of A over B would be, yes, Kylie, the opposite of B over A, because perpendicular, you flip it and make it opposite. Slope of -2. Parallel line, Logan? Yes, -2. Perpendicular, Heather? Yes, half. One more. Slope of 2/3. Actually, two more. Slope of 2/3. Lila? Parallel? 2/3. Perpendicular, Zoe? -3/2. Yes. 0. The slope is 0. Parallel lines have the same slope. So, Connor, it will be 0. How about perpendicular? What's the negative reciprocal of a 0 slope? Clayton, yes. Undefined. Undefined. Okay? All right, we're going to talk about this golf ball example. Okay? The path of a golf ball bouncing off a curved wall on a miniature golf course is shown below. Lines A and B appear to be perpendicular. Are they? What do we know about perpendicular lines? The negative or opposite reciprocal. Okay? This one in y-intercept form, dividing all terms by 3 for line A, y equals 2/3 x minus 1/3. How about line B? Y equals -3/2 x plus 10.5. Are their slopes the reciprocals of each other? And is one positive and one negative? Yes. So then we have right here a 90-degree angle because they are perpendicular. Let's look. A hockey puck leaves the blade of a hockey stick and bounces off a wall and travels in a new direction as shown. Let me make sure that I've got this example. Okay. Go ahead and go back to the original. That was that. Okay. So you could have drawn that diagram on your golf ball example. Here's the hockey puck example. Here's what I want you to do. I want you to go ahead and draw it on your graph. Here we have the starting point at -4, 1. Okay? Here the puck is hitting the wall at 0, 8. And it's then reflected off of -4, 16. Okay? All right, and this talks us through how we can do this. Here's the two lines. This is line number 1. Once it hits, this is line number 2. When we're looking at perpendicular lines, we want to compare the slope. So we need to find the slope of line 1. How am I going to find the slope? Well, there's one of two ways I could do that. Okay? For line 1, I'm going to choose to use my slope equation, which is y2 minus y1 over x2 minus x1. y2, 8, minus y1, 0, over x2, 0, minus x1, -4. 8 minus 0 is 8. 8 or 0 minus negative or plus is 4. So the slope of line 1 is 2 over 1, or 2. Okay? Line 2. Let me ask you something. Do I need to write this? It says to write an equation that models that, write an equation that models this. Do I need to write an equation, or do I just need to find the slopes? I really just need to find the slopes because that's all I'm going to compare. So let's find the slope of this line once it bounces off the wall and goes up here. I'm going to use y2 minus y1 over x2 minus x1 again. y2, 16, minus y1, 8, over x2, negative 4, minus x1, 0. 16 minus 8 is 8. Negative 4 minus 0 is negative 4. 8 over negative 4 is negative 2 over 1. 4, negative 2. Does the path form a right angle? You decide. Think about how you know. So does the path form a right angle? Why is this not going to work for me? No. Hopefully you said no, because perpendicular lines have slopes that are opposite reciprocals. Okay? The slopes in the previous example are not opposites reciprocals. They are only opposites. They are not reciprocals of each other. Okay? Those were some real life situations with the golf ball and the hockey puck. And that concludes video 2.